Welcome to this video on OSWAP Top 10 Security Risk. In this video, we are going to continue our conversation about OSWAP Top 10. And if you recall from the previous video, this is mainly focused on web-based application, but it plays a vital role at the source code level for a lot of different software applications. And that's why you are likely to see question on the exam that relates to OSWAP Top 10. Now we have covered the top 10 for 2017. In this video, I want to focus on 2021. And as you can see, the most of 2017 will map to the 2021 top 10 risk. But there are a few that are new. And you could see them here. You have A04, A08 and A10. So that's what we are going to focus on in this particular video. So let's start with A04, which is the insecure design. This is pretty straightforward, where if you have ineffective security or privacy control, you are going to have a problem in your design and we need to build those in. So we want to conduct regular risk analysis and implement secure system design or mitigated control for things that we have discovered. Threat modeling became a huge part of that, where risk analysis is done on the back end after we have built the threat model. This will help us with design, where things are configured, the architecture and the engineering, all those things in consideration. We talked a lot about that in domain 3 if you want to go back to that. The next one being number 8. This is software and data integrity failures. This is caused by lack of integrity protection in software code. So what we want to do is restrict or prevent automated update to software. This is very important. This has to do with the patch management, which we talked about in another video, and also has to do with software libraries. If you have software libraries, this can automatically update as well. So we want to make sure that those are coming from trusted vendor, trusted repos or repositories, and that they are digitally signed so that we can verify the integrity of those files. We also want to do checksums against the hash values, those kind of things. Okay, and update services probably being the biggest risk here, because if you're doing automated updates, you are not checking integrity unless it built into the system, and that's really what this risk is focused on. So this is pretty straightforward. We want to follow a good CM process to configuration management process, and we want to do manual updates where possible or implement proper checks when we are doing automated updates. And that's take us to number 10, which is server-side request forgery, also called SSRF attack. So this occurs when a server-side application access remote resources without validating the web address. So that sounds bad, and it is. This will exploit a trusted connection between web server and external resources. This is a lot like cross-site scripting attack, but there's a few difference happening here. Really, what we are targeting is the web address or the uniform resource locator, the URL. And here's a very simple example of how this might work. We have the attacker, and the attacker is going to inject that script on the web server, and how they are going to do is that they are gonna access the website and then inject it into the server. So what's end up happening is, let's say customer is looking for something on the website. Inside the code, you are going to have variety of different commands from HTML perspective, but what I want you to look at here in this talk API, what's happening is web server is calling an external URL, and it's right here. It's going over port 8080 and it's calling the product stock, and then whatever the file is within the particular directory, so it's contacting another web server, going into the directory of that other web server and then producing that content back onto the web page. So once you identify that and you find the script in the code, you can actually modify that and send it somewhere else. In this case, why don't we look at the admin directory on the web server itself, and that will produce the content that are in the admin directory. So instead of seeing the stock, maybe it's like t-shirt or coffee mugs or whiskey glasses, now we are looking at the content in the admin folder. So this can actually help attacker discover what's on the web server, and then they can start focusing on other exploit based on contents in the particular directory. By modifying this code, we can direct it to whatever or whenever we want. We can redirect it to a folder. We can redirect it to a malicious website. We can redirect it to a malicious script if we want. The idea here is that server is often protected by network level firewall. It might even be protected by a web-based firewall, but this can be defeated if the web code is not protected properly. So again, the source code is the target here. In fact, if you are familiar with the Capital One bank hack that occurred in 2019, this is exactly how this hack was pulled off. So that's all happened just from injecting a script right onto the website. Now there's another version of this called cross-site request forgery or CSRF attack. This occurs when victim executed unwanted action on a web application in which they are currently authenticated. So this is targeting a pre-authenticated session between the web browser, which is the client, and a web server. So you have that level of trust that builds in, and we are going to exploit or take advantage of that. And here's a simple example of how that would work. Again, if you have a victim and let's say they are already authenticated to Amazon.com, how many people actually log out of the website every single time they done using it? Most of us don't. We just close the tab or we close the browser and we go on about our business. You still have an authenticated session token between you and the website. So you have the trust between the website and the web server, essentially between the victim and the web server in this regard. So what ends up happening is an attacker is gonna assume that most of us are already logged into Amazon. We are already logged into Facebook. We are already logged into Google. We are already logged into all this website we use every single day. So they will send you a phishing email. They will send you an email, and inside that email is a link that say, hey, there's an awesome deal on overstock.com. Now there is an website called overstock.com, but overstock.com is not real. It's malicious and it's the attacker website. The victim will click on that link and they are taken to that malicious site, and it looks exactly like overstock.com, look exactly like that site. But what they don't know is there is a hidden form inside that website that's going to contain a script that's going to buy something from Amazon.com. Let's say they start looking for whiskey glasses that look like really good deal, but I really want some whiskey glasses, or I want a new decanter or something like that. And then when they put in the whiskey decanter and they click search, they now activate the script, and that hidden form and the code, the HTML code that's in that form, will buy something from Amazon.com. And the session token that already pre-existed is what used to make the purchase. Because you are already authenticated, you are gonna be redirected, and the victim will not even know this happened. And within this code, it will already modify the delivery address and other things. It will just use the pre-authenticated token and also probably the credit card and other information. Pretty crazy, right? Now, in order to defend against you want to validate the client provided input. You also want to whitelist web addresses and the ports. If you don't want to use port 8080 for HTTP, you need to whitelist the allowed port 443 in this case to do HTTPS only, things like that. And You also want to permit the traffic by exception and deny everything else by default. So we want to identify what traffic is going to exist between the web servers. We want to whitelist those, put them into the web servers, and only allow them to talk to each other, and that's it. The bottom line for this video is to understand the security risk and mitigation we talked about here, and definitely understand the 2021 risk just in case you see them on the exam.